Okay, our next speaker is getting set up, Benjamin Zysberg he's the lead engineer at Total Immersion. He's been using computers since being four and learned to program because he wanted to create his own video games. He graduated in 2005 in Paris with a master's degree in computer science with specialization in virtual reality. He worked as a seismological research lab at a cell phone provider and in a French bank, and joined Total Immersion in 2008 as a professional service engineer. So in 2010, he moved to Los Angeles office of the company and was promoted to lead engineer. His job consists of providing technical assistance to the creative strategists, managing resources, assessing new technologies, training Total Immersion's partners, and developing prototypes. So with that being said, here is Benjamin.
So I'm sorry for my terrible accent. As you can hear, I'm French. And like you say in the US, pardon my French. So today I'm here to present Diffusion. Diffusion is the SDK made by Total Immersion. Total Immersion was started about 13 years ago as one of the first AR player. And we have made our SDK, we have progressed it, and we made some improvements during the years. So Diffusion provides at the same time the rendering and the tracking technology. There is two main components. Our tracking technology is called Diffusion Computer Vision, and our rendering technology is called Diffusion Augmented Reality. What we call Diffusion Studio is the tool sets you're going to use to create the AR experiences, and then you will be able to deploy these experiences on multiple platforms. So you develop on a PC, Windows, and then you are able to port these experiences on what we call Diffusion Pro. It's for kiosk or live events. For example, tomorrow at the keynote, we will be being part of the show. Diffusion Home is when you want to deploy on a desktop application, also on Windows. And we have a mobile solution to develop applications on iOS and Android. Finally, we also have a plugin for Flash. For Flash, we don't provide the rendering because Flash has its own rendering. And we are compatible with Stage 3D. We just provide the tracking component. Like I said, one platform to develop, the PC, and then you can deploy what we call the AR scenario on all these platforms. So Total Immersion not only provides this SDK, but also we do all kinds of applications. Our main application is called TryLife, and it's a fitting solution for glasses, clothes, furniture, both online, on mobile, in-store, events, retails. We do a lot of digital marketing, whether advert gaming, commercials, promotions, same thing on multiple platforms. And we have also a few B2C applications. We made our own game last year called Skinvaders. When you develop with Diffusion, you are using every tools we provide to create your application, from modeling to deploying, meaning that we are providing the exporters for 3ds Max and Maya. We are providing Diffusion Studio to develop your AR experience, and we are providing everything to deploy. So we are providing the libraries on iOS and Android. We are providing what we call the home player to make a downloadable application. And we are providing the Pro player to make some kiosk and live events. So you don't need any other tools, you just need Diffusion. Our rendering is good, it's based on Augur 3D, but our core technology, Diffusion CV, that's what we're proud of. we can recognize a whole bunch of natural elements for any use case possible. We can recognize 1D and 2D barcodes, like QR codes. We can recognize multiple types of marker, 3 by 3 or 5 by 5, up to 10, 24 markers. We have motion detection, and we have markerless tracking. Markerless tracking, we can track faces, any kind of 2D object, any kind of 3D object, and we can track multiple objects at the same time. Also, we have a way to track locally on the device, very fast, a large database of images. On a computer, it's about to 1,000 images. On a cell phone, it's about 500. But Diffusion doesn't only give you access to our markerless tracking technology. It gives you access, if you're on a device, to all the sensors. For example, when we do marker tracking, we are using the attitude, the gyroscope, and the accelerometer to enhance the tracking stability. You also have access to the GPS. And all that interactions, you're going to use the Lua language to develop them. We choose Lua because it's a very reliable script language that's easy to learn. Basically, you know JavaScript, you know Lua. That's well recognized into the industry. And you don't have to recompile. I'm going to show an example after that. But even if it's a script language, we have integrated a debugger into Diffusion. So it's a very efficient way to develop. Anytime you can modify some script, just reload your project. Your modifications are taken account, and you can test. Finally, we're not limited to webcams or mobile camera. We can interact with basically any direct show device that can plug on your computer. LG camera, Kinect, special camera like the UI. If you can see them in direct show, then we can import the live video feed into Diffusion, and we can augment it. I'm going to show you how it works. So I'm going to create a new project. Let's show you from start to finish. That's our user interface. It's based on Qt, meaning that you can easily modify the way you want to order elements. First, we need a way to access our live video capture. To do that, we go to the video tool. You can manually set the parameters, or you can just import the templates that we have created for you. So as you can see, we have binded all the possible video capture for Android, HD, iOS, back and front camera, or webcam. And I hit this one. So I'm going to save that as a resource to my project. Now we need a calibration. Because we are doing AR, we want the virtual 3D camera to be mapped with the same physical parameters as my physical camera. That's why we can choose all the parameters like the focal or the optical center. We can even use a mirror to do some calibration. Same thing, we have already pre-made most of the calibration you're going to use for also iOS, Android, webcam, or HD. Now I'm going to assign everything, so I'm going to start by creating the access to my camera. I'm going to create a video texture to display it. I'm going to show this video texture on my viewport. And I'm going to assign my physical calibration to my virtual camera. First step, I can see myself. Now we need some assets. So we're going to import these assets into our project. These assets have been pre-exported by our 3D artists. Directly inside the software, we have a way to visualize these assets before they are being used. Now the most important, we need to create the tracking, the link between my face and some kind of reference point in the world. To do that, I'm going to open our tracking tool. Doing face tracking is easy. I just have to create a target, tell that it's a face, and automatically it's going to pick my face and follow it in the 3D space. As you can see, it's quite robust. Now I'm going to save this tracking scenario as part of the resources of my project. And I'm going to use it. So that's the part when you need to start doing some Lua scripts. Since we don't have much time, I'm going to directly import the script, but I'm going to show you how it works. It's quite simple. I've imported my script, now I can add it into my scene. Just give him a better name. And open the editor. That's my script. Basically what I start to do is I get an access to my scene so that I can instance into my scripts all the objects I've declared inside my hierarchy. Then I access my camera because that's my reference point. I'll always get the tracking position from my camera. Then I access my video capture. And then I'm going to put the tracking information into a dummy 3D object called obj tracking. So I need to create this object. Almost done. One last thing. I need to bind my glasses to my dummy 3D object. So first, I need to add my glasses inside the scene. and I need to tell them that they're going to be linked to the tracking, so that whenever the tracking shows up, my glasses are going to show up. That's why I made this hierarchy. Thing. There you go. As you can see, I have a little light issue, so I'm going to adjust that. And if I want, directly on screen, I can modify the position of my glasses to make them fit better, or change the scale. Left. Almost done. Once you have a new application, what you're going to do is you're going to export. For example, you want to export for mobile. Let's say for iOS. First, you're going to start by selecting the assets you want to export, because even if you can have the same AR scenario for multiple platforms, you want some of the assets to be dedicated to a specific platform. For example, you know that on Android you're going to target high-end devices, so you're going to use glasses with way more polygons. You're going to select a folder to export. And one last thing, you're going to set the bundle ID you're going to use in your iOS application. The result of your export is all these files that you have created, and now you can integrate that as part of assets of your iOS or Android application. And we even have created a program that allows you to test without any compilation. It's called the test player. I don't think I have time to I don't think I have time to show it today, but I'm going to show it tomorrow during the mobile SDK session. Any question? We never use Vuforia. We have our own tracking technology for everything.
Is there a way to get this project later so I can look at it? Because we didn't go through it so fast.
Yeah.
I can't see what's printed there.
Yeah, sure. Yes. Actually, what we are developing right now is a solution called ARSDP. It's a way to deliver content from the cloud. So the good thing about our technology is since what we call the AR scenario is just an asset inside your iOS and application, you can actually download any kind of external assets. Once your scenario is done, as add-ons from the cloud or from anywhere, you can add this. We have a solution called Try Live Eyewear, where when users download it for the first time, they just get the tracking component. All the glasses that they can try are downloaded on the fly. That's also something I'm going to showcase tomorrow afternoon. Morning. Morning.
All right.
Yeah.
Thank you. Oh, one
When
more?
did you start to develop this SDK, and how many people helped you to develop this, and how many licensing so far, and how many applications?
Wow. So we've been developing that for about 13 years. Internally, we have done about 1,000 projects, and we have worldwide 100 partners that are using our technology. I don't know the number of licenses yet, honestly.
Last question.
Only face tracking or hand tracking, 3D tracking? What's the tracking protocol?
We do marker tracking, markerless tracking, so any kind of natural interactions.
Markerless tracking, is that 2D or 3D?
We do both, and complex 3D objects.